All right, we're going to go over this Quizizz number 2 review under Unit 5. It is now posted under the Unit Review. Click here. It's going to take you to a new Quizizz game, and it'll bring you up to a 10-question Quizizz, a little bit extra review for your test. So the first question is, for the exponential equation, y equals 3 times 0.25 to the x power, click all that apply. When you look at the graph, you want to think about, does it go up or down as it goes to the right? As you can see, this graph goes down as it goes to the right. It flat lines. The more it approaches infinity, it gets closer and closer to 0. So it's exponential decay. And the y-intercept is 3. So we represent exponential decay, but we also want to say the y-intercept is 3. And that comes also from this number, and there's nothing being added at the end, so it's going to be 3. All right. Oh, I'm in first place. Next question. The graph of f of x equals 4 to the x is transformed to the following function. G of x equals 4 to the x minus 6 minus 6. 4 raised to the parentheses, x minus 6. Those parentheses are important, otherwise it will put this minus 6 down here. Now let's take a look at what's going on. If I transformed it from 4 to the x power, you can see this graph went right and down. So it goes right 6 and down 6. So in the exponent, you'll see the minus 6, that's the right. If that were plus 6, it'd be left. And down here, minus 6 means down 6. If it were plus 6, it would be up. Right 6 and down 6. Next question. The exponential function below, what is the y-intercept? Well, there's a couple ways you can get the y-intercept. You can take this first number and add the amount it's shifting up or down. So this would be 5 plus 2, which is 7. If you weren't sure about that rule, you would say the graph of this function will cross the y-axis at 7. So it has a y-intercept of 5 plus 2, which is 7. For the exponential function below, which asymptote is correct? Exponential functions have horizontal asymptotes, which means either going left or right, they will approach a horizontal line and never go below that line. It's always going to be how much it's shifted up or down. A horizontal line is y equals a number. So if you type in y equals 2 and maybe zoom out a little bit, you can see that that graph will never touch the 2 or go below it. So it'll approach that line but never go below it. A vertical asymptote, which this does not have, would be x equals a number. So if I said x equals 2, this graph will eventually cross 2. So it's not an asymptote. And the same with 5. If I put x equals 5, this graph will eventually cross 5. And I think we have found a spot where they're a little bit higher. So you see the red's above there. So it does not have vertical asymptotes. It has a horizontal asymptote, y equals 2. For the logarithmic function below, which is the correct asymptote? Well, we can graph this again. Y equals log x minus 3 plus 1. Let me click home so I can see what's going on here. Logarithms are inverses of exponentials, so they have vertical asymptotes. So it'll go up and down forever, but it will never go below. And this actually keeps going down, but the graph doesn't allow you to see that. It'll never actually touch 3 or be below 3. So the magic line is whatever's in here. If it goes right 3, then that vertical asymptote would be x equals 3. And if that said x plus 3, then the vertical asymptote would be x equals negative 3. And as you can zoom out, you can see that. So the minus 3 means it goes right 3. It's got a vertical asymptote of x equals 3. Vertical x equals 3. Come on. For the logarithmic function below, which is true? So I realized I did not have that logarithmic function in there. So now I have it in there. It'll be corrected on your end. For the logarithmic function below, which is true, it's the same one as the previous problem. Y equals the log parentheses x minus 3 plus 1. So let's analyze that, shall we? The domain and range. The domain for logarithmic functions is limited to what the asymptote is. So since the asymptote is at x equals 3, everything above 3 can be entered in, but you can't enter in 3 because you get 0 and you can't put a log of 0. It's not possible. And you can't put anything below 0, so you couldn't put like 4. So that'd be -1. Impossible. But anything above 3 in this case, like 3.1, that'll work. You know, you can go anything higher, you can put 4 in there. The point is that since the asymptote is 3, x is greater than 3, that means your domain is x is greater than 3. Now that's represented not here, but here, 3 to infinity. X is greater than 3 is 3 to infinity. And then the range will always go up and down forever for logarithms. As you can see, it's going to keep going up, it's going to keep going up, and it'll certainly keep going down. That line would continue to go down and approach that asymptote. So that is going to be your answer. All right, for the next question. For the exponential function pictured in the table, what is the y-intercept? The y-intercept is when x equals 0. So we have a table that starts at 3. We do have to work backwards. So I'm going to rewrite this table. We'll do it in blue. We'll do it over here. You have 6, 128, 5, 64, 4, 32, and 3 and 16. And we have to get this all the way to when 0 is your x value. So I would extend that table and figure out the pattern and then keep it going until you get to where you need to go. So hopefully you can figure out the pattern. These numbers are just multiplied by a certain amount each time. So 16 times 2 would give you 32, times 2 is 64, times 2 is 128. So if we work backwards, we could divide 16 by 2 and you would get 8. So for x is 2, f of x is 8. And then you could go to 1, and that would be 4. And then finally going to 0, that would give you 2. So your y-intercept is going to be whenever x is 0. So it's going to be 2. Your answer will be 2. Now you're going to be asked to compare that to a quadratic on your test. And the quadratic will be graphed. So you can look at the graph and see where it crosses and make that comparison, which one is bigger or smaller, or if they're the same. Next question. Two functions are shown below. F of x equals 2 to the x minus 5 plus 1, and g of x equals x squared minus 5x plus 5. For which positive integer values of x is f of x greater than g of x? Pick all that apply. We need to graph it. So we'll start by graphing the exponential function. Make sure you graph it accurately. And then we're going to also graph the quadratic function so we can make that comparison. Now, as we said before in the lessons, these guys crisscross and intersect each other quite a bit. They typically intersect each other by starting at the quadratic being higher than the exponent. Then the exponential becomes bigger than the quadratic. So between these two numbers, the exponential is bigger. So anything less than 4.178 and greater than 1.062 would be that. So if I do less than 4, That would be one option, anything less than 4. And technically we should probably say greater than 2, but or greater than 1, but I did not include that on there. So less than 4 will be your answer here. And then if you go up here, the quadratic is greater. So it will be greater up until it hits this point at 11.198. So anything higher than 11.198 would have the exponential f of x be greater than g of x. Well, 11 isn't really going to be working because 11 at technically when x is 11, the quadratic is bigger. So it's not going to be 11. So we're going to bump that up to 12, and that'll be your answer on this one. So between less than 4, really less than 4 and greater than 1, and then greater than 12, these two functions are, the exponential function will be bigger than the quadratic function. That was a mouthful, kind of hard to explain, but that is the correct answer for this one. Okay, question 9. We didn't cover properties of exponents when we were teaching this unit. That is something that you probably are exposed to in math too. So what I'm going to ask you to do on this problem is compare the graphs, okay? We're going to pick up to 3 answers, and there should be 3 graphs that overlap each other. Those are going to be your the ones that are equivalent to each other. So what I'm going to start with is just typing in one at a time the exponential graphs. Click home so you can see a graph, and you can see this first one is exponential growth here. And then the next one, 64 parentheses 4 raised to the 3x. You can see that that's different. So these two are not equivalent. So let's keep those two on there. And let's do 4 raised to the 3 plus 3x. Now you might notice that a new graph has not been drawn, but rather the second one was simply overlapped, which means these two are the same expression, just written differently. If you look at the fourth one, that's parentheses 4 to the 3rd power times 4 raised to the x power. That put a new graph over here, so that's different than these two, and that's different, obviously. So the last one is what we want to determine if it's going to be the same as this one or not. So we'll do parentheses 4 times 4 to the x power, close it up, and then raise that to the 3rd. And it didn't make any new graph, and it ended up overlapping these two graphs. And let me hide this green one, and let me hide this black one, and you can see that all 3 of these are the same thing. So that second one, 3rd one, and the 5th one are all equivalent, and that's really all you need to do on this problem. And for our last question, here we go. This is kind of a throwback from yesterday. I just wanted to make sure we really hit home exponential growth and decay. So a city's population currently has 1,457,010 people. If the population has been growing exponentially at a rate of 4.5% a year for the past 10 years, about how many people were in the city 10 years ago? Well, let me get my pen out so we can write a couple things down. The generic yearly exponential growth function is the amount at the end is equal to the amount at the beginning, parentheses 1 plus the rate to the t power. Now here's what we don't have. We don't have the beginning amount. We have the end amount. That's the current population, and we're trying to figure out what 10 years ago was. So we're just going to work backwards. T is going to be 10. This is going to be your capital A. So it's going to be 1,457,010 equals my unknown, parentheses, since my rate is 4.5%, it'll be 1.045, 1 plus 0.045. And we know T is going to be 10. So that's going to be 10. So we have a couple ways that we can approach this. We can figure out 1.045 to the 10 power and divide that from 1,457,010. We can take our answer choice and plug it in to see which one gets you closest to this number. We could also graph it. So we have a few options. Let's explore all of them and see what one works best for you, shall we? So let's go by plugging in. If I said my initial population was 1,029,325, and I did 1.045 raised to the 10 power, I would get a population of 1,598,510, which is more than what we have here. So that's not going to work. So let's go to the 82209. That gives you 1,273,759, too small. So let's go up to the 938. $209, and that's 1,457,009, which we can bump that 9 up to 10. So that's the same thing. So it's going to be that answer. Another approach you can do is you can call this X, and you can set it equal to Y equals 1,457,010, and you can zoom that out. And there's your starting amount, 938,209.072. You could also figure out 1.045 raised to the 10th power, and you could divide this number by that number. So you could say 1,457,010 divided by 1.55296,942,173. Try to be as accurate as possible. And you see that original number is 938,209. So I got a few options. However, ultimately, your job is to get the answer. So there's the answer. We are good to go. And I won. I'm so happy. I had some stiff competition, but it looks like I came out on top. And now I'll challenge you to do it better than me, which means play it again, watch the video, do it multiple times until you have the highest score. See you next time.